Welcome to lecture number 101 of digital electronics. In this lecture, we are going to design a binary coded decimal counter, that is BCD counter, and check whether it is self-starting. So the question is design a BCD counter, and check whether it is self-starting. And using JK flip-flops. Now coming into binary coded decimal counter, that is BCD counter. Step 1, you need to find number of flip-flops. How will you find a number of flip-flops? That is the question here. Now BCD means it is binary coded decimal. Decimals needs to be counted from 0 to 9. So what is the binary count of 9? The binary count of 9 is 1001. Therefore, the binary count of 0 is 0000. So there are 4 bits here. Therefore, each flip-flop can store only 1 bit. Therefore, number of flip-flops required is 4. That is step 1. Now step 2 is, in the question it is asked that you need to use JK flip-flop. Therefore, you should draw the excitation table of JK flip-flop. Okay. So you should draw the present state and next state. And after present state and next state, you should find J and K. So 0 0 0 1 1 0 1 1. 0 0 means it is 0 don't care. 1 1 means it is don't care 0. 0 1 means it is set, so it is 1 don't care. 1 0 means it is reset, so it is don't care 1. Okay. So that is the excitation table of JK flip-flop. Now coming to the step 3. Step 3 is draw the state diagram. Okay. So to draw the state diagram, we are having 0 0 0 0. That is 0, then comes 1, then you will get 2, 0 1 0, that is 2. Now comes 3, that is 0 0 1 1, 3. Then 4, that is 0 1 0 0, that is 4. Then 5, that is 0 1 0 1, that is 5. Then comes 6. That is 0 1 1 0, that is 6. Then comes 7, that is 0 1 1 1, that is 7. Then comes 8. 8 is 1 0 0. 8 is 1 0 0 0. Then comes 9. This 1 0 0 1. This is 8 and this is 9. And then it goes back to 0. So this is the state diagram. Now coming into the present state and state table along with the excitation table. Present state, next state table along with the excitation table of JK. Flip-flop. Okay. So since there are 4 bits, you should have 4 present states. Okay. Or 4 bits present state. That is, present state is Q4, Q3, Q2, Q1. Similarly, next state is also Q4, Q3, Q2, Q1. So you should have 4 flip-flops, right? So you should have J4, K4. Then comes J3, K3. Then comes J2, K2. Then comes J1, K1. Okay. So 0 1 2 means 0 0 1 0. 3 4 5 0 1 0 1. 6 it is 0 1 1 0. 7 8 and it is only up to 9. This 9. Now it is 0, it will go to next state as 1. 0 0 0 1. 1 means it is going to 2. 0 0 1 0. 2 means it will go to 3, that is 0, 0, 1, 1. 3 means it will go to 4, that is 0, 1, 0, 0. 4 means it will go to 5, that is 0, 1, 0, 1. 5 means it will go to 6, 0, 1, 1, 0. 6 means it will go to 7, that is 0, 1, 1, 1. 7 means it will go to 8, that is 1, 0, 0, 0. 8 means it should go to 9, that is 1, 0, 0, 1. 9 means it will go back to 0. So it is 0, 0, 0, 0. It is going back to 0. Now coming into first, we will deal with J4 and K4. Okay. So if you need to find the values of J4 and K4, it is in reference to the excitation level of Jk along with the present state and next state of Q4 only. So 0 to 0. 0 to 0 means it is 0, don't care. 0 to 0, 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 it is 0, don't care. 0 to 0, it is 0, don't care. Now comes 0 to 1. 0 to 1 means it is set, so it is 1, don't care. 1 to 1 means it is don't care 0. 1 to 0 means 1 to 0 means it is reset, so it is don't care 1. So you got J4 and K4. Now come to J3 and K3. J3 and K3 means you should go with the present state and next state of Q3. You take Q3 only. 0 to 0, it is 0, don't care. 0 to 0, 0, don't care. 0 to 0, it is 0, don't care. 0 to 1, 1, don't care. 1 to 1, it is don't care 0. 1 to 1, okay. 1 to 1, don't care 0. 1 to 1, don't care 0. 1 to 0, it is reset, so it is don't care 1. Right. 0 to 0. 0 to 0, it is 0, don't care. 0 to 0, it is 0, don't care. So you got J3 and K3. Now coming into J2 and K2. Here you need to take what? Here you need to take present state Q2 and next state Q2. Now coming into J2 and Q2. So it is 0 to 0. 0 to 0 means it is 0, don't care. 0 to 1 is 0 to 1 means set. So it is 1, don't care. 1 to 1, don't care 0. 1 to 0. 1 to 0 it is reset. So it is don't care 1. 0 to 0 it is 0, don't care. 0 to 1, 1, don't care. Okay. 1 to 1, don't care 0. 1 to 1, okay. 1 to 0, it is reset, so it is don't care 1. 0 to 0, it is 0, don't care. 0 to 0, it is 0, don't care. So you got J2 and K2. Now coming into J1 and K1, you should look for present state Q1 and next state Q1. 0 to 1, 1, don't care. 1 to 0, don't care 1. 0 to 1, 1, don't care. 1 to 0, it is don't care 1. Now 0 to 1, it is 1, don't care. 1 to 0, it is don't care 1. 0 to 1. 0 to 1 means it is 1, don't care. 1 to 0. 1 to 0, it is don't care 1. 0 to 1, it is set, that is 1, don't care. 1 to 0, it is reset, so it is don't care 1. So if you are writing the decimal equivalence here of present state, it is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now here the invalid states. The invalid states are 10, 11, 12, 13, 14 and 15. Because using a 4-bit you can go up to 15. So these are invalid states. So whatever comes in the invalid states, we are taking it as, whatever J and K comes during these invalid states, we are taking it as don't care. Now coming into J1 and K1, first we will go in that order. If you are going with the J1 and K1, you will get 1 don't care, 1 don't care, 1 don't care, etc. And all other elements are don't care. That means if it is 10, 11, 12, 13 and 14, it is don't care. That means similarly for K1. So you can take J1 is equal to 1 as well as K1 is equal to 1. That is from this table directly you can take J1 is equal to 1 as well as K1 is equal to 1. because you are getting 1 in between and all others are becoming don't care, means J1 is equal to 1 and K1 is equal to 1. Now you need to derive the expression for J4, K4, J3, K3, J2 and K2. So you need total 6 K-maps. So first I am going to derive for J4. Okay. First I am going to derive for J4. Okay. If it is J4, what is J4? J4 comes where? Okay. So this is J4. I'm going to derive the expression for J4. So I am drawing a 4 variable K-map. Okay. 1, 2, 3. 1, 2, 3. So this is Q4, Q3, Q2, Q1. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now already 10, 11, 12, 13, 14 and 15 are don't cares because they are invalid states. Now here which is 1, 7 is 1, all others are 0. 7 is becoming 1 and all others are 0, right? So sorry, 7 is 1, 8 and 9 is don't care. 8 and 9 is also don't care and all others are 0. Yeah, okay. Now coming into expression of that. Okay. So here we can club these two. If you are clubbing these two, which is common here, which is common here. In these two, this Q3 is common. Here Q1 and Q2 is common. Therefore, we can write J4 as J4 is equal to Q1, Q2, Q3. Q1, Q2, Q3. That is the common factors in that selection. Now coming into K4, we should draw a 4 variable K-map for K4. Okay. 1, 2, 3. 1, 2, 3. So we have Q4, Q3, Q2, Q1. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. So here we have a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Directly you can say 10, 11, 12, 13, 14 and 15 are don't cares. Now coming into K4, which is 0. 8 is 0, 9 is 1. 8 is 0, 9 is 1. All others are don't care. So here what we can club? So here we can club in octet. So we can club these 8. So we are clubbing these 8 which is common. Yeah, already Q1 is common. Therefore we can write K4 is equal to Q1. Okay. Because here you have Q2 bar Q1, this is Q2 Q1. You can club column wise. Therefore we can write K4 is equal to Q1 directly. Now I am going to club K4 is there. Now I am going to find J3 and K3. So to find the expression of J3, I am drawing a 4 variable K-map. Drawing a 4 variable K-map. 1, 2, 3. 1, 2, 3. So here what I am having is Q4, Q3, Q2, Q1. So 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Yeah. So here what I am having is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you can have 10, 11, 12, 13, 14 and 15 as don't care. Now coming into, we need to find J3, right? To find J3, what we have? 0, okay. So 0, 1, 2 is 0. 0, 1 and 2 it is 0. Now coming into 3 it is 1. 3 it is 1. Now 4 to 7 it is don't care. 4, 5, 6 and 7 it is don't care. Now 8 and 9 it is 0. 8 and 9 it is remaining as 0. Therefore what we can do? Therefore here we can club 2. So if we are clubbing in quad, we can club these two. Okay. If you are clubbing that two, what will we get? Which is common? Q2, Q1. Therefore we can write J3 is equal to Q2, Q1. J3 is equal to Q2, Q1. That is the expression we are getting. Now I need to find the expression for K3. Again I am drawing a 4 variable K map. Okay. So 1, 2, 3. 1, 2, 3. So here I am having Q4, Q3, Q2, Q1. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Now coming into K3. 0, 1, 2, 3 it is don't care. 0, 1, 2, 3 it is don't care. Now coming into 4, 5, 6 it is 0. 4, 5 and 6 it is 0. Yeah. 4, 5 and 6 it is 0. 7, 8, 7 is 1, 8 and 9 is don't care. 7 is 1, 8 and 9 is don't care. Of course, all others are also don't care. Okay. Again, if you are looking to K3, yeah, okay, if you are looking to K3, again you are getting that we can club in quad. So which is common? Q2, Q1. Therefore we can write K3 is also is equal to Q2, Q1. Therefore we can see that J3 is equal to K3. Okay. J3 is equal to K3. Now coming into J2, K2. Okay. Coming into J2 and K2. That is the next part. Okay. So I am drawing a 4 variable K map for J2. A 4 variable K map for J2. 1, 2, 3. 1, 2, 3. Okay. So this Q4, Q3, Q2, Q1. So it is 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. For J2, 0 it is 0, 1, 2, 3 it is 1, don't care. 1, 2, 3. 1, 2, 3 is 1, don't care. 1, 2, 3. Now coming into 4 it is 0. 4 it is 0. Now coming into 4 it is 0. 5 is 1, 6 and 7 is don't care. 5 is 1, 6 and 7 is don't care. Okay. Now 8 and 9 is 0. 8 and 9 is 0. All others are don't care. Okay. Therefore, how we can club? So here we can club 4. We can club these 4, right? So here which is common? Q4 bar is common. Here what is common? Q1 is common. Therefore, we can write J2 is equal to Q4 bar Q1. Now coming into the last K-map, that is K2. So I will draw K2 here. Okay. The K-map that is K2. Okay. Right. Drawing a 4-variable K-map. Okay. 1, 2, 3. 1, 2, 3. So this is Q4, Q3, Q2, Q1. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. So here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Now coming into K2, don't get 0, 1. Don't care 0, 1. Then don't care 0, 1. Again don't care 0, 1. Don't care 0, 1. Now 8 and 9 is don't care. 8 and 9 is don't care. Of course, all others are also don't care. Yeah. Okay, what is the system for K2? That is the question. Okay. Now coming into K2, you can club is set as an octet. You will get an octet here. Club as an octet. So what you get? You will get K2 is equal to, which is common. Only Q1 is common. So we can write K2 is equal to Q1. Okay. So the expressions what we are getting is J1 is equal to 1, K1 is equal to 1, then J2 is equal to Q4 bar Q1, K2 is equal to Q1, J3 is equal to Q2 Q1, J3 is equal to K3 is equal to Q2 Q1. Q2 Q1. Now J4 is equal to Q1 Q2 Q3, Q1 Q2 Q3, and K4 is equal to Q1. Okay. Now let me draw the logic circuit. Okay. First I will start with J1 K1. J1 K1 and having the clock. Okay. This is Q1 bar. Then J2 K2, Q2 bar. Same clock is applied here. Okay. Now comes to J3 K3, Q3 bar. Again we are applying the same clock. Now comes to J4 K4, Q4 bar. We are having the same clock. This is a synchronous circuit, you are having the same clock. Okay. So that is ready. Now we can draw what is J1 and K1. J1 and K1 both are is equal to 1. So we can give J1 and K1 both is equal to 1. Now what is J2? J2 is Q4 bar Q1. Okay. So Q1 is here. You can put an AND gate here. The Q4 bar here, Q4 bar Q1, right? Q4 bar Q1. So there is an AND gate that goes into J2. What is K2? K2 is equal to Q1. So you can draw it directly. K2 is equal to Q1. That is it. Now what is J3? That is Q2 Q1. Okay, so Q1 is here. Q2 is here. You put an AND gate. You go to J3. J3 is same as K3. That is it. Okay. Now what is J4? J4 is Q1, Q2, Q3. So here you are having Q1, Q2. You AND it with Q3. You will get J4. But what is K4? K4 you will get it as Q1. K4 you are getting it as Q1. Okay. Now we can take Q1 is taken out. Q2 is taken out. Q3 is taken out. Q4 is taken out. These are the outputs. Now we have preset and clear. 1, 2, 3, 4. This is preset. Okay. So these things you can short it and give it as a preset. Here there is clear. Okay. Give it into clear. Okay. Now preset and clear is also ready. Okay, so this is the logic circuit of the entire counter. Now here you need to check for, now this is part 1. So now part 1 is over. Now you need to check for self-starting. Check for self-starting. Okay. To check for self-starting, what is, before that let me write this for J1. J1 is equal to K1 is equal to 1. Now what is J2? J2 is equal to Q4 bar Q1. J2 it is equal to Q4 bar Q1. And what is K2? K2 is equal to Q1. Q1. What is J1? J1 is equal to K1. That is equal to, sorry, no, J3. J3 is equal to K3. Right. That is equal to Q2 Q1. That is equal to Q2 Q1. Now what is J4? J4 is equal to Q1 Q2 Q3. Q1 Q2 Q3. Now comes to K4. K4 is equal to Q1. K4 is equal to Q1. Now in this BCD counter, which are the invalid states? The invalid states are 10, 11, 12, 13, 14 and 15. Now let us check for these invalid states in this design. Okay. So what is the present state? Present state you can write it as Q4, Q3, Q2, Q1. Then what is equivalent J4, K4. Then comes J1, J3, K3. Then J2, K2. Then comes J1, K1. After that it will go to next state. From there you can determine the next state. Next state Q4, Q3, Q2, Q1. So 10 is 1 0 1 0. 11 is 1 0 1 1. 12 is 1 1 0 0. 13 is 1 1 0 1. 14 is 1 1 1 0. 15 is 1 1 1 1. Now what is J1 and K1? Everything is equal to 1 1 1 1 1 1. Okay. K1 is also is equal to 1. Okay. J1 and K1 both are is equal to 1. Now what is this one? J2 is Q4 bar Q1. Sorry, I will go with J4. J4 is Q1, Q2, Q3. Q1, Q2, Q3. So it is 0, 0, 0, 0, 0, 1. What is K4? K4 is Q1. So it is 0, 1, 0, 1, 0, 1. That is K4. Now, now coming into J3, K3. What is J3? J3 and K3 is Q2, Q1. Q2, Q1 it is 0, 0, 1, 1, 0, 0. So that is 0, 0. 1, 0. That is 0, 0, 1. That is 1, 1. Okay. Now what is J2? Q4 bar Q1. So 0 dot 0. 0 dot 0 it is 0. 0 dot 1 it is 0. 0 dot 0 it is 0. 0 dot 0 that is 0. 0 dot 0 it is 0. 0 dot 1 it is 0. Okay. Now what is K2? K2 is Q1. That is 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Now you need to check for the next state. That is the question here. Okay. Now coming into next state, Q4, Q3, Q2, Q1. If it is Q4, Q4 is 1. Q4 is 1 and J4, K4 is equal to 0. If J4 and K4 is equal to 0, 0 don't care. That means it is there is no change. Okay. Right. If J4 and K4 is equal to 0, that means set and reset button is 0. So it is no change. So Q4 will remain as it is. 0, 1. So it is reset. So it is 1 will be resetted to 0. Right? Okay. 1, 0. 1 and it is 0. 0, 0. 0, 0 means it will remain there. So 1 will remain there. 0, 1. It is reset. So 1 is reset to 0. 0, 0. 1 will remain. 1, 1. Okay. J4, K4. If it is 1, 1, what happens? Yeah. If it is 1, 1. Oh, sorry. Yeah, J4, K4 is 1, 1. What happens? Let me check. If J4 and K4, if both are 1. So here it is 1. So you can make it as okay. 1, 1 means you can make next state as J is 1, K is 1. Okay. So you can make next state as 1. No problem. You can make next state as okay, 1 second. If there is 1, 1, this 1, 1 and present state is 1. You can say that okay, it can go to any state. That means it can go to 1 or it can go to 0. If it is 1, 1, if it is 1, 1, it can go to 1 or it can go to 0. So, but now I am taking it as 1. No problem. Taking it as 1. Now coming into Q3. Okay. If it is 0, 0, since I am making it as no change, 1, 1 means it should remain as 1 itself. Okay. Now what is Q3? 0 to 0. 0, 0, there is no change. So it is 0. 0, 1, 1. Right? Yeah, 1, 1 means it should remain there. Right? Yeah, it is 0. J3 and K3. Both are is equal to 1. And Q3 you can make it as 1. You are taking a standard. Okay. Now, yeah. Now 1 is there, 0, 0 is there. 1 is there, 0, 0 is there. So there is no change. 1 is there, 0, 0 is there. There is no change. 1 is there, 0, 0 is there. So there is no change. So 1 will remain. 1 is there, 1, 1 is there. So you can make it as 1 only. Okay. Right. Q3. Sorry. If it is, okay. There is a mistake over here. If J4, if J is equal to K, and if J is equal to K is equal to 1, it is acting in toggle mode, right? It is acting in toggle mode, right? So you can have Q3, that is 1 is here. So J3 and K3 is equal to 1. So 1 will be toggled to 0. So similarly, what is Q3? Now, whether in case 1, 1 is there, yeah, here 1, 1 is there, so 0 will be toggled to 1. here in the case of 1 here, if it is Q4 and J4 and Q4 is equal to 1, J4 and Q4 is equal to 1, this Q4 will be toggled to 0. There's a mistake out there. Yeah, Q4 will be toggled to 0. In another case, 1 is there. Yeah, that's it. Okay, so it is 0, 1, 1, 0. Okay. Now coming into Q2. Now what is Q2? 1. Q2 means you need to check for J2, K2. 1, 0, 0. So it is no change. So 1 will remain. 1, 0, 1. 0, 1 means it is a reset. 0, 1 means this reset means it is 0. Now 0, 0, 0, 0, 0 and 0, 0 means it is remaining there. So 0 is there. Now comes 0, 0, 1. It is reset. So 0 will be reset as 0. 1, 0, 0. So it will remain there. Now 1, 1, 1. Right? 1 means it is 0, 1. That means it will be set. So it is 1. So it is 1, 0, 0, 1. 1, 1. Right? It is Q2. Q2 is 1. Sorry. See here last element J2 K2. K2 is 1, so it is reset. So 1 will be reset to 0. There is a mistake over there. Right. Now coming into Q1. Now coming into Q1 means 0 to 0, 0, then 1, 1. It will be toggled, so it will be 1, 1, 1, 1. It will be toggled, so it will become 0, 0, 1, 1. So 0 becomes 1, 1, 1, 1. It will become 1, 1, 1. So 1 will be toggled to 0, 0, 1, 1. So 0 will be toggled to 1. Now 1, 1, 1. So 1 will be toggled to 0. Now let us check the next state. 1, 0, 1, 1. What is it? It is 10. It is 1, 0, 1, 1. 1, 0, 1, 1. It is 11. This is 10, 11, 12, 13, 14, 15. Now here what is it? If it is 11, 0, 1, 0, 0. What is it? 8. Right? 1, 1, 0, 1. So it is. So this is 4. 11 means it is 4. That is a mistake. 0, 1, 0, 0. It is 4. It is coming as 4. 1, 1, 0, 1. So it is 8 plus 4. 8 plus 4. 12. 12 plus 1. It is 13. Then if it is 13, 0, 1, 0, 0. It is coming to 4. 1, 1, 1, 1. It is 15. This is 0. So what is actually happening? If 10 is coming, 10 will go to 11 and 11 will go to 4. Right? Again, 4 is a valid state. Now if 12 is coming, if 12 is coming, it will go to 13 and 13 will go to 4. Again, if 14 is coming, 14 will go to 15 and 15 will go to 0. That is it. So if you are redrawing the state diagram, it will be like this: 0, 1, 2, 0, 1, 2. Then comes 3. Then comes 4. Then comes 5. Then comes 6. Then comes 7. Then comes 8. And at last you will get 9. I am just drawing the state diagram. That is a modified state diagram. This is a modified state diagram which you are drawing. Okay. Now coming into the modified state diagram. If I am going to the state 10, 10 means it will come to 11, then it comes to 4. 10 means next state it will come to 11, then it will go to 4. Right? Now, if it is 12, it will come to 13, and 13 means it will go to 4. 12 means it will go to 13. Then after 13, it will go to 4. Then, if it is 14, it will go to 15. If it is 14, it will go to 15. Then from 15 it will go to 0. From 15 it will go to 0. So what does that mean? If the counter falls into any of the invalid states, if the counter falls into any of the invalid states, then what happens? If invalid states 12 is coming, it will go to 13, then it will go to 4. If it is coming to 10, it will go to 11, then it will go to 4. If it is 14, it will go to 15, and then it will go to 0. Then it is returning back to valid states. Returning back to valid states. Therefore, what we can say? Therefore, we can say that the counter is self-starting. Therefore, the counter is self-starting. Okay. So, to have a brief about this lecture. Okay. In this question, what is designed? A BCD counter is designed, and we have checked whether it is self-starting. So initially we have designed a BCD counter based on the JK flip-flop, and we have drawn the logic circuit. And after that, using these invalid states, we have found the present state and next state using the invalid states. And from the invalid states, and we have found that if it is falling to 10, it will go to 11, and from 11 it will come back to 4. If it is falling in 12, it goes to 13, and from 13 it comes back to 4 in the next clock pulses. And if it is 14, it goes to 15 and come back and goes to 0. That means if the counter encounters any invalid state in 1 or 2 clock pulses, it is coming back to the valid state, which means that the counter is remaining as self-starting. Okay. So that is all in this lecture. Thank you. And in the next lecture, we will be seeing one more counter. After that, we will be moving into shift registers and shift register counters. And at last, we will be dealing with asynchronous counters. Thank you.